Hi everyone. So today's lesson we're going to be looking at the properties and how we solve for different lengths of another special right triangle, but in this case it's going to be called a 30, 60, 90 special right triangle. And again, so what I'm going to do, like I kind of did very similar to your old notes on the 45, 45, 90, I'm going to show you kind of where these properties derive from, okay? So if we think back to a type of triangle, an equilateral triangle, right? You guys know an equilateral triangle, all three sides are the same measurement, right? And again, indicated by the tick marks. And we know all three angles are also the same measurement. Now, you guys know all three angles have to be 60, right? Because three angles in a triangle have to add up to 180 degrees, right? So I technically got that 60 just by doing 180 divided by 3, that means each angle in here is 60. So when I draw the altitude of this triangle, so from the top vertex all the way straight down to the bottom of the triangle, what I'm actually doing is that I'm drawing a perpendicular bisector. So bisector meaning whatever this side is getting cut into two smaller equal parts, and perpendicular meaning that it's forming those two 90-degree angles there. Okay, so essentially what's happening is I'm again forming a special triangle that if I redrew over here, right, that perpendicular bisector not only bisected the side of this triangle here that I'm pointing to, but it also bisected that angle of 60 degrees. It cut it into 30 and 30. So if you guys see the triangle I redrew down here, right, we have that same 60-degree angle, we have that 90-degree angle, and now that top angle here is now 30 because half of 60 is 30 and 30, okay? So again, I highlighted the different sides here just to kind of visually show you the differences. We always know, again, the hypotenuse is opposite my little box here, right? So I'm just going to write hypotenuse. And now your two legs here, you guys need to notice that we actually now have a shorter leg and a longer leg. And you guys have a little bit of experience dealing with shorter versus longer leg when we did a geometric mean, right? So just note that we're no longer working with isosceles legs. We are working with a short leg and a long leg. So I'm just going to show my blue leg here is my short leg. And then the green one is the long leg. Okay? I'm going to hold off on deriving where the special relationships come from just to kind of save us some time. But what you guys can kind of think of is that back to this equilateral triangle, let's say I knew all these sides here were 8, right? 8, 8, and 8, right? And I took those measurements, I went over here and put them on my triangle. So I know this hypotenuse here, right, highlighted in orange, let's say this was 8 centimeters, right? And then when I drew in that perpendicular bisector, like I said, it bisected that side into two smaller equal parts. So if that entire length was 8, that means it got cut into 4 and 4, right? So I'm just going to put a 4 centimeters here. Okay, and you know what the heck, let's actually derive this and figure out what this third side would be here. Okay, using, again, we can use Pythagorean theorem to solve for that third side, right? We know the leg squared plus the leg squared equals the hypotenuse squared. Okay, so I'm just going to write my formula up here. Leg squared plus leg squared is equal to the hypotenuse squared. Now, one of my legs is unknown, so I'm going to make that x squared plus, well, I know my other leg is 4, so 4 squared is equal to my hypotenuse squared, which is 8, so 8 squared, okay? So simplifying this, I have x squared plus 16 is equal to 64. I solve for x squared by subtracting 16 on both sides. I get x squared is equal to, let's see, and again, you're gonna want to have a calculator handy with these guys because we're gonna have to do some simplifying of radicals. It's gonna give me a 48. And again, to get rid of that exponent of 2, I need to take the square root. So x is equal to the square root of 48, and I want to break down that 48. I want to simplify it using a perfect square as a factor, okay? 4 goes into 48, but there's technically a bigger perfect square that goes into 48, which is 16, right? So 16 times 3 would give me a 48, so radical 16 times a radical 3 would give me a radical 48. So I'm going to cross out that radical 16 because I know the square root of 16 is 4, and I'm left with 4 root 3. So technically my x here is a 4 root 3 centimeters. So what's the relationship here between my short leg, my long leg, and, my short leg, my hypotenuse, and my long leg? Well, essentially, guys, everything revolves around the short leg, okay? So whatever your short leg is, I'm just going to make that some number x, okay? Your hypotenuse is always double it, right? That's a nice, easy relationship. So whatever your short leg is, multiply it by 2 to get your hypotenuse. So if this is x, that means my hypotenuse is going to be 2x, right? Now, in terms of my long leg, what's the relationship between a 4 and a 4 root 3? Well, getting from a 4 to a 4 root 3, all you're doing is multiplying by root 3. So that means whatever your short leg is, you're going to take that short leg and simply just multiply it by radical 3 to get your long leg. Okay, so that's your simple kind of relationships that we're going to be using to solve for missing side lengths. So you have 3 cases here, guys. Okay, so your cases are you can either be given the short leg, you could be given the long leg, or you could be given the hypotenuse. Okay, so I'm going to run through all 3 cases with you right now. All right, so given the short leg, again, this is like your easiest case, guys. All right, so anytime you're given the short leg, right, I can figure out my hypotenuse, right, just by doubling it or multiplying it by 2. So 3 times 2 means y would have to be 6 centimeters, okay? Now x, again, my long leg here is just a short leg times root 3. So if my short leg is 3, it's just simply 3 root 3 centimeters. Now it says round to the nearest hundredth. So again, if I want to actually convert 3 root 3 into a decimal, I'm going to type in my 3, type the, oops, if you guys see it, 3, the radical symbol, and then my times button, 3, and that should give me about 5.20, let's say. Okay, so 5.20. All right, so that's our nice easy case. Now hypotenuse is also a pretty easy case too. Right, so instead of multiplying by 2, I'm going to divide by 2 to get my short leg, right? So if 8's my hypotenuse, I'm going to divide by 2 to get my short leg here. So 8 divided by 2 would give me 4 centimeters, right? And again, anytime you have your short leg, finding the long leg, we're just multiplying by root 3. So y is simply just 4 root 3 centimeters. And if I bring back out my calculator and convert that, so I'm going to type in my 3, my radical, and then times 4, we should get 6.93 centimeters. Okay, so really these are all shortcuts here, guys. You don't have to go doing Pythagorean theorem for every single problem. You're just really using your shortcuts and your formulas to figure out the missing dimensions. Now, your last case here is when they're given the long leg. And I say this is maybe your trickiest one, only because when you start getting whole numbers there, you have to do a little bit of rationalizing, okay? But in this specific case, it's actually going to be pretty easy. My long leg here is 10 root 3. So if I did get my long leg from my short leg, right, in this example, we figured out that the short leg was 4 centimeters, and I said, okay, well, to get my long one, all I got to do is multiply by 4 root 3, or sorry, by root 3. So I end up getting 4 root 3 for my long leg. So instead of multiplying by radical 3 to get my long leg, they're giving me the long leg, so I got to work backwards and now divide by root 3. So if I do 10 root 3 divided by root 3, those root 3's cancel, and that means my short leg is 10, and I double 10 to get my hypotenuse, right? So my short leg of x would be 10 centimeters, and my hypotenuse would be 20 centimeters. Okay, not so bad there. Okay, now our special cases for case 3 given the long leg. Now, lucky for you guys, we've actually already done a ton of practice dividing radicals and rationalizing in a sense. You guys did that a lot with the 45, 45, 90. So I can actually use my shortcuts for these as well. I'm going to show you. But again, I'm going to kind of walk you through rationalizing and then show you the shortcut we can use for the long leg when it's given as a whole number here. Okay? So when my long leg is a whole number, so again, if I'm given the long leg to find the short leg, what I need to do is just divide by root 3. Okay? So if I go ahead and rationalize, do 9 divided by radical 3. We know we can't have a radical in the denominator, so to rationalize, we're just going to multiply both top and bottom by root 3. Radical 3 and radical 3. So radical 3 times radical 3 is going to give me radical 9, or the square root of 9, and I know the square root of 9 is just a whole number of 3, right? The whole point of multiplying by that radical is to get rid of it, right? Because I'm left with a perfect square, which simplifies to a whole number of 3. In my numerator, I'm left with 9 root 3, right? 9 root 3. I can go ahead and simplify my 9 divided by 3 to get 3, and then I'm left over with root 3 centimeters. So my short leg here is going to be 3 root 3 centimeters. Now all I have to do to find my hypotenuse is double this or multiply it by 2, okay? When I'm timesing this by 2 or multiplying it by 2, I'm only multiplying that outside number 3 by 2. I'm not touching the number under the radical. Okay, so 3 times 2 is going to give me 6, followed by that root 3. So y is going to be 6 root 3 centimeters. So essentially you're only doubling the number on the outside there, right? You could think of it as it was like 3x, right? If you're going to double 3x, you would get 6x. Treat that radical 3 as like a variable, sort of, okay? All right, now shortcut, guys, right? Now since we're working with radical 3, okay, your shortcut here would be taking that whole number of 24 And instead of dividing it by 2, right, because that's what we did with the 45, 45, 90 for the shortcut, you're going to divide it by 3. So if I take that whole number of 24 and divide it by 3, I get 8. And then I just take that whole number of 8 and multiply by root 3. And that would give me 8 root 3 for my short leg. So 8 radical 3 centimeters. And again, now to find my hypotenuse, I'm just doubling that 8 root 3. So the only thing I'm doubling is that 8. So it becomes now 16 root 3 centimeters for my hypotenuse. Okay? Last one here. Now 20, you technically could use your shortcut for, right? But it's not a nice number that's divisible by 3. But we can still do it anyway. Okay? So I'm going to show you. So I can go ahead and take that 20 and I can divide it by 3. Okay, you can just leave it as 20 divided by 3 if you want. Okay, if you actually want to take your calculator and divide it, let's see what happens when we do that. Yeah, we're going to get 6.66666 repeating, so maybe we can just keep it as 20 divided by 3 there. Okay, so if 20 divided by 3, again, I'm just going to leave it as 20 divided by 3. Now all I got to do is take that and multiply it by root 3. So all that's going to turn into, guys, when I multiply a fraction times my radical 3 there, I'm just going to essentially stick it right next to the number in the numerator. So it's going to become 20 root 3 divided by 3. So you're kind of just pairing those together, right? Because technically that radical 3 is over a 1. I'd multiply those two together, get 20 root 3. I multiply 3 times 1 to get 3. So I can keep x as 20 radical 3 over 3. Now when doubling this number to get my hypotenuse, all you are doubling is the number in the numerator. You're not touching the number under the radical, and you're not touching the number in the denominator. So simply that's going to turn to 40 root 3 divided by 3. Okay? So again, it's the same property, the same tricks I'm using over and over and over. It's just what happens when we get different sorts of numbers and radicals, how those properties kind of play out. Okay? So if you want to kind of pause this video right now, guys, and at least try these 3 examples, that might not be a bad idea. If you're still kind of trying to work through this and figure it out, you can kind of keep the video rolling and just kind of go along with me as I finish up with 4, 5, and 6 here, okay? So 6, what I'll do, guys, if you've got that shortcut down pat, you can go ahead and use it. If you're still unsure about the shortcut and rather just rationalize, I'll do these last 3 rationalizing, okay? So 6, I know, is my long leg, and to get to my short leg, I have to divide by root 3. So if I do 6 divided by root 3, I have to rationalize and multiply the denominator and numerator by radical 3 of root 3, okay? Radical 3 times radical 3 gives me a whole number of 3, and 6 times radical 3 just gives me 6 radical 3. I can divide out that 6 and 3, so 6 divided by 3 would give me 2, followed by that radical 3. So x, my short leg here, is 2 root 3 centimeters. And again, for my hypotenuse, I'm just multiplying that by 2. So the only number I'm multiplying by 2 is that number out front. So it's going to become 4 root 3 centimeters for my hypotenuse. Okay? For 15, okay, so again, 15, I'm dividing it by radical 3. I rationalize, multiply by radical 3 top and bottom. Radical 3 times radical 3 gives me 3. I get 15 root 3 in the numerator. Okay, 15 divided by 3 is going to give me a 5, and then I leave that root 3 next to it, so 5 radical 3 centimeters. And once again, going from short leg to hypotenuse, we are just multiplying this by 2. Okay, and the only number we are multiplying by 2 is a number out front, so this becomes 10 root 3 centimeters. All right? And last one, example 6. Okay, so 16, it's not a number divisible by 3. So again, it's going to kind of be a very similar example to example 3 up above. So if I go ahead and if I wanted to rationalize, right, do 16 divided by root 3. Okay, I multiply by root 3 top and bottom. We know radical 3 times radical 3 is a square root of 9, or radical 9. Square root of 9 is just 3. And I'm left with 16 root 3 up at the top. I can just keep this as a final answer here, guys, right? 16 root 3 divided by 3, and again, to get my hypotenuse, I am just doubling this number. So doubling this means I'm only doubling the 16. So it's going to become 32 root 3 divided by